Welcome back to another episode of the Blockburner Podcast. I'm your host, William, always here with your co-host, Iman.
What's going on, dude?
On the sticks, we got TJ.
Hello.
And joining us today, finally, we got Jordan, CEO of D-Merchant Labs, longtime developer and engineer with ICP. Thank you for joining us, Jordan.
Yep, happy to be here. Thank you.
All right.
Good to talk to you. So we had an interview about a month ago with Bob Bodley, I think.
Yeah, it was a month. Yeah.
Yeah, like, we've been trying our hardest to summon Bob for about a year now.
Yeah.
Because
Oh, wow.
it seems like anytime anything is developing in the Bitcoin L1 space, the meta protocol space, whatever you want to call it, Bob seems to always have like these insanely
thorough explanations.
Coherent takes on the situation, right? So and then suddenly with like a month or so ago, a new one emerged centered around TAP, right? Where this TAP and ICP integration is announced. And a lot of the people don't necessarily know what this all means. So we do, in a sense, because we've always really wanted to understand ICP and its technology since the beginning.
Mm-hmm.
But we haven't been able to take the deep dive for a lot of reasons. From our perspective, it's always been kind of daunting for some reason. It seems overwhelming, like what it is ICP is building, or has built.
They have a lot of words on their website, dude.
It's pretty insane. So we're glad to have you here because you seem to have like the most, you've actually interfaced with ICP probably more than anybody we've seen out there. And, you can help us enlighten ourselves and our community exactly what's going on with ICP. So if you can, just give us like a brief background about yourself, your involvement with ICP, how that all came about.
Okay, yeah, awesome. So 2017, I was at the end of my university time studying computer science, and I was in a distributed systems class. I've always loved open source. I think I've always loved like permissionless innovation and the decentralized nature of the internet and like the IP protocol, TCP, all that stuff. So that stuff was always amazing to me. And around 2017, I had heard about Bitcoin enough times that I decided to finally look into it. So I never had really paid attention to it before. So, when I look into things, I don't know, a lot of times I just listen to as many podcasts as I can, maybe watch YouTube videos, start Googling to understand things. Learning about Bitcoin quickly led to learning about Ethereum. Mm-hmm. And I started to get the feeling that these were almost like the ultimate decentralized or distributed systems. They just had this latent power that I could feel from them. So around, summer 2017, I'm looking into all this stuff. Maybe fall 2017, somehow, some way, I find the Dfinity website. I'm like, what is this? And I'm very much of an engineering mindset. I love computer science and digging into the architecture of all these things. And so I was just trying to understand basically, every protocol and which of these blockchains is going to actually work out, which one is going to actually be able to scale, who actually is going to be able to implement sharding and not like a limited form of sharding, but hopefully a unbounded, transparent form of sharding. I had been Bob Bodley and I started a company around that time in 2016, I believe. We both went to the same university, and I was in charge of all the software and all the hardware mostly being, just the servers, the cloud stuff. So all that stuff was super complicated. Like just, to prepare for scale, to get, your front ends served up appropriately, talking to your back end, having all your database stuff work, and doing it in a way where the software itself can grow and not be overwhelmingly complicated for, new devs to come on and for things to change. It was so complicated. And I was seeing that in this blockchain ecosystem, it might be possible to replace this legacy cloud stack with something else. So I was always in search of that. And Dfinity at the time seemed extremely promising. Dfinity was its name at the time. The project is now called the Internet Computer Protocol, or ICP. Dfinity is the Swiss foundation that created the protocol. And I started consuming everything that I could from the founder. His name is Dominic Williams. listening to like all his talks, anything on YouTube, just anything I could find, because the way he described, extending the internet through a protocol and creating, for him, the way he described it was he wanted to create basically scalable or maybe even unbounded virtual machines. That seemed an amazing vision to me. It seemed like, yes, that's really what we want to go for. And as I got into studying many different protocols over the next couple of years, my family, so I grew up in the San Francisco Bay Area. My family has since moved, but at the time they still lived there. So I was going to school in Utah, but I was always just going back to visit and to go to conferences. So it was like really easy to just, and I would knock on the Dfinity doors. I went to their headquarters a couple times. I just tried to be at every event, and not just for ICP, but everything basically, all the stuff going on in San Francisco. Headed out to Wyoming. That's where I met Charles Hoskinson. I was really trying to really dive in to understand who is going to have the best scalable blockchain. And around 2019, Dfinity actually released some code that you could use. You could actually start programming in their language called Motoko. Personally, I'm not a fan of creating new domain-specific languages. So I was more excited for their Rust CDK to come out. Finally, maybe 9-ish months, a year later, the Rust CDK did come out in 2020. That's when I was like, all right, we can, I had played around with Motoko a bit, but it's like, let me try to do something serious. I pulled GraphQL off the shelf. GraphQL is an amazing query language similar to SQL, but it's much more declarative. I pulled that library off the shelf. I don't think I had to make any major changes to it. And, wrote up a simple resolver or something, deployed it, at least to the local network. I might have even deployed it to their testnet, and it worked. It just worked. It returned a query. It was amazing. Tweeted about it. That was kind of the start of like, oh man, we might be able to get this thing to replace the crazy cloud stack that I have to use for everything up until that point. And basically, I did a grant in 2021 to build a GraphQL database for the internet computer. That was a dream I'd always had, to build basically an infinitely scalable GraphQL database. It's not infinitely scalable, by the way. ICP does have a number of limitations. I would love to get into the architecture of all that so people can really understand, what it's capable of, where it might lack, so that we have a true, clear understanding of what's going on. Mm-hmm. And then started my company in 2022, Demerchant Labs. We have grant funding from the Dfinity Foundation to build the TypeScript and JavaScript and Python SDKs. That's our main focus, and we do a number of other things as well.
So that means that do you have hands-on on this tool called Azel?
Yeah, Azel is our project. So yep.
Oh, okay. Yeah. So the only reason why I bring it up is because we've been talking to Benny, the founder of Track, and he said that he's been using Azel and it's been amazing.
Yeah, the same.
Oh, awesome! That's nice to hear. Yeah.
Yep.
We are programming that thing every day. So yep.
That's awesome, dude. So I just want to make a comment. Azel, using TypeScript and JavaScript to create smart contracts is kind of like the best idea, just because everybody knows JavaScript and TypeScript if you're a developer, right? So it's a smart move, because like you're saying, if you have to use a domain-specific programming language, you're going to have a hard onboarding situation for developers.
Yeah.
And so this is...
Yeah, JavaScript and Python have like 3 decades of material and experience, and 20 million developers each or something crazy.
Yeah, so that's right.
Well, take us into that architecture design that you were kind of referring to behind ICP, because, what is it that's actually, in relation to that architecture that enables this tech stack that seems so...
I think it's important to have just a little bit more context. So just for a little bit of our background, that way Jordan, that way that you can sort of contextualize the explanation of ICP, is we've been talking about ordinals since it dropped, essentially. And then all of a sudden we started partnering with Track and Tap, and we created just a meta protocol that exists on top of ordinals, on top of the Tap ecosystem. Mm-hmm. And then Benny announces a partnership with ICP, that he's going to be leveraging ICP as sort of like a second layer sort of solution. And so we just come from like the Bitcoin side, the Ordinal side. And so we're very, very curious as to how ICP plays a role as far as manipulating UTXOs. How does a developer develop a smart contract that actually manipulates these UTXOs? Like, how does that actually work? So that's kind of where we come from. And so very interested to hear how this like architecture is designed and all that.
Yeah, awesome. Yep. I like to be very clear and very technical, and I also skew towards the critical side. So I'll try to keep it balanced, but we can dig into anything that you want. I just want to make sure we get a really secure understanding of this. So
sure.
Basically, how the internet computer works at the highest level is it's basically a network of subnetworks. So you have the entire internet computer protocol. It's going to be partitioned into subnetworks, subnets, that's what we call them. Every subnet is running the same consensus protocol. It's called Internet Computer Consensus, ICC. There's a paper on it, you can read about it. There's a whole lot of documentation at the lowest levels for anybody who really wants to dig in. Internet Computer Consensus, my understanding is it's a Byzantine fault-tolerant protocol in kind of like the PBFT family. So similar protocols would be Tendermint, would be Hot Stuff, would be there's a few others. They're all kind of they're in a similar family. ICC has taken some design decisions to it has some nice properties. If you go read the paper, it kind of explains these things. And basically, it's a protocol where you have Byzantine fault tolerance created by having replicated computation. So the subnets on the internet computer have between right now 13 and 40 nodes. Most subnets have 13 nodes. So by default, if you just want to make an app and deploy it, I believe you can now choose the subnet, but most will be 13. So probably you'll deploy to a 13-node subnet. Your application, which we call a canister, a canister is just a WebAssembly module, basically. TypeScript, JavaScript, Rust, Motoko, whatever, compile it down, deploy it. It's going to go to a subnet, and that module will be replicated across all 13 nodes. The nodes will all be executing all messages coming in. They're going to gossip those messages between them. And every state change is going to be done by every single machine. They're all going to come to consensus and strictly order the messages. And then they're going to just execute them in the WASM environment, which has been made deterministic. And that's how it works. So it's very, very simple at the core level. It's just a bunch of subnets, 13 to 40 nodes each, and replicated computation. So the security of your app is basically controlled by the subnet. If you deploy to 13-node subnet, you have the bounds on the Byzantine fault tolerance protocol, by the way. And if people don't understand what Byzantine fault tolerance is, it's basically if you have Byzantine fault tolerance, that means that generally speaking, you can have a certain number of participants or nodes or processes become faulty for any reason. They could just shut down. They could get struck by lightning. A hurricane could come through. A deep state actor could take them over. They could be malicious in many different ways. It doesn't matter. That's what being Byzantine means. It's arbitrary fault, and you are tolerant up to a certain threshold of faults. So on the internet computer, that threshold is described like this: F is less than n over 3. F is the number of faulty nodes. N is the number of nodes in the subnet. And divided by 3 is 3. So basically, you can have up to just less than 1/3 of the nodes be faulty. So in a 13-node subnet, you could have 4 nodes be faulty. Once you have 5 nodes be faulty, once 5 nodes are faulty, the consensus is broken. You cannot finalize anymore. If you increase the size of the subnet, obviously you increase the actual practical number of nodes that can be faulty. So a 40-node subnet, which is the main subnet that has the most secure application, like the ICP token itself is on this 40-node subnet. that has more, it should be harder to take that one down than like a 13 node subnet, for example. Mm-hmm. Now, these are all individual subnets. And so to really be a universal system, the subnets need to be able to communicate with each other. If I'm a canister on one subnet, I want to be able to talk to other subnets. And as a developer, I don't want that to be a complicated process, right? I don't want to have to like find a subnet number and put it in and I don't know, do these crazy things. And so the Internet Computer, probably its key innovation is called chain key signatures or chain key technology. My understanding is these are fancy BLS signatures that basically have an eternal key pair. So every subnet has a public key that will never change. Mm-hmm. The nodes in the subnet can change. They can swap out. Like, I don't know, if you find a malicious nodes, you could, put proposals up to take them down. But that public key will never change. And so signatures from these subnets can be verified instantly. And you don't have to aggregate a bunch of different signatures of the nodes. It doesn't matter who the nodes are. You can simply verify just one signature from the subnet. And actually, all the subnets derive from a master chain key pair, essentially, mm-hmm. which, basically, because they all derive from that, you actually only need one public key, and you can verify anything from any subnet. Mm-hmm. So there's a lot of assumptions in there, but that's basically the model, at least how I understand it. So what's nice about that is it's technically just very simple to verify messages coming from the Internet Computer or messages between subnets in the Internet Computer. And that creates kind of this, one giant computer. It's not perfect. There's a number of things I think are actually weaknesses that I think should be improved, but that's the current security model, and it might be sufficient for some use cases, and it might not be sufficient for other use cases. You just have to analyze it like that. So
I have a question. So if you deploy an app in one subnet and I deploy another app in another subnet, and I need, let's say, an API from your application, right? Do we need signatures from the subnet for that purpose, or is it just a simple API call?
As a developer, it's just a simple API call. I just say, for example, in Azel, the TypeScript SDK, it's even as simple as, const result equals a way to fetch ICP : / the canister ID / the method I want, and then put the arbs in. So it looks just like an HTTP request.
Oh, I see. Okay.
It'll be different in Rust and Motoko, but yeah, it's a simple API request. Under the hood, though, to do this securely, these subnets are basically signing messages.
I see.
And coming to consensus on those, like, oh, is it verified from the subnet? Yes. We all agree in this subnet, we all agree that this is a correct message. Okay, then we're going to not reject it. And then that it's safe, as in,
it's
at least
coming from
2/3 of the other subnet agreed.
Yeah, so basically these signatures confirm that the data that's going within this API call is actually coming from that subnet.
Yep.
Okay.
And it went through consensus correctly on this subnet.
Yeah.
It only means that 2/3 of the nodes agreed. It doesn't mean that it's correct. It means that 2/3 of nodes agree.
Yeah. Okay. Okay, that's interesting.
So is there any part of the protocol? I don't know. Like we've seen this in other ecosystems, like some way of maintaining reputation amongst node operators within the system, like slashing mechanisms and such. If there's some instance or whatever cause for collusion to occur, right? Because we've seen this architecture before, right? Where it's kind of like you condense the consensus down to a much smaller figure as opposed to tens of thousands of nodes across the planet. That's why things are slow on Bitcoin and Ethereum, right? So the thesis is let's condense this down to a smaller pool.
It's like a parachain.
Yeah, exactly, a parachain or delegated proof of stake, whatever you want to call it, right? These ideas of how you reduce it down to increase the scalability, right? Now all of a sudden, everything's solved, but it introduces new
security risks. Yeah.
Yeah. So how is ICP, addressing those potential attack vectors?
Well, and here's where I think these are weaknesses of the Internet Computer Protocol. I've been pushing for a long time. I have a number of points that I would like to improve. So there is no slashing currently. There is no. I'm not sure there's a truly automatic means to remove nodes from the subnet. They can be removed, but generally these are done through proposals. The whole system is controlled by a DAO.
Okay.
Called the Network Nervous System. This DAO is controlled by the ICP token holders in a liquid democracy. So basically, I believe what happens is if a faulty node is observed, a proposal is put up to remove that node, and it's voted on. Now, right now, the DAO doesn't have the checks and balances that I personally believe it should have. It allows power to accumulate in a small number of hands through delegation. So it's possible that one entity can have most of the voting power delegated to it. So, people had to make those choices, but it does allow that power to accumulate. And right now, Dfinity has most of the voting power, I think greater than 90% on certain proposal types that change the protocol and do things like this. So right now, Dfinity, with that voting power that is delegated to them, is controlling these things.
Yeah.
So if you want to, we can talk about a number of things I think could be improved, or we could continue to analyze the current architecture to see its strengths and weaknesses.
We could stay on architecture for now, because I am curious. Whenever this recent, I guess, IT infrastructure collapse happened, in the last few days, I did see Dominic tweet out this would never happen if the internet was built on this framework of an internet computer protocol. So
are you talking about CrowdStrike?
When everyone's computers turn blue?
Yeah, CrowdStrike. Yeah.
Yeah. So I saw the tweet, right? And everyone's like, okay, well, explain, right? If the internet was built under this protocol standard, right? What actually changes, and how does that prevent these types of incidents from occurring?
Yeah, I mean, so I obviously observed what was happening. I haven't studied deeply what happened. Do you guys know exactly what happened? What I heard is there was a faulty configuration file that was pushed.
Yeah, exactly. So I think there was an automatic update on these Windows machines, and there must have been some sort of lack of quality control, and it got pushed out publicly. And then all of a sudden, all these computers blue screen of death.
Yeah, I don't see how ICP would improve that, because you could.
I don't think so.
If you don't review your code and you push out a fault, even if that configuration is stored on the internet computer, that configuration will be very secure, right? You're not going to have the nodes messing with it, but the people, this was not a malicious attack. This was just human error.
Yeah.
So I don't see how ICP helps there. But if it was an attack, that's where ICP would help, because you would have to compromise at least 5 nodes on a 13-node subnet, and as you increase the subnet size, it would get harder and harder to attack. So I don't see how it helps in the CrowdStrike situation, but maybe a similar situation where it was actually malicious, maybe that could have helped.
So if you were to advise a developer who's trying to build, I don't know, something of relative significance as far as security concern, let's call some sort of DeFi application where there's billions of dollars at stake, right? What would you recommend, considering maybe to spread out the relevance of these canisters individually in order to mitigate disaster in the event?
Yeah, because
go ahead.
Yeah, securing billions of dollars on a 13-node subnet doesn't feel that great.
Right.
Do you guys all agree with that?
Definitely.
Yeah, I mean, we store billions of dollars, I guess,
and a centralized bank, right?
Or right, or a single smart contract
too. Yeah.
So it definitely seems like we need to improve our design considerations for this amount of money.
So the current, and we haven't talked about threshold ECDSA or Schnorr or EDDSA yet, but the Internet Computer allows you to create threshold key pairs on these on the subnets essentially. So it's the same concept. You basically have, a subnet, and then there are threshold key shares that are never on one machine. And so you get Byzantine fault tolerance of a Bitcoin key pair essentially. So it's like a decentralized Bitcoin key pair. And that's nice, but you need to make sure, for example, on a 13 node subnet, that's probably a little small. So the Bitcoin subnet, I believe, has 28 nodes. That's a little bit better, but unfortunately, it's not F is less than N over 3. It's a different scheme. You only need 1/3 of the subnet members to sign. So on a 28 node subnet, you need, I believe, 10 nodes. I might be doing off by one errors, but you get the idea.
Yeah.
So I believe you need 10 nodes to sign right now. So the question is that good enough? 10 nodes, and right now the subnets are static, generally speaking, as in, a node operator gets put in, they're generally not going to get taken out unless, I don't know, they're faulty, or unless the subnets are being reorganized to ensure decentralization. That's one thing, is that the system is set up right now to ensure as much as we can the decentralization of the subnet. So they're trying to make sure that a subnet is composed, for example, of completely independent node operators. Whereas, if it was completely, it's permissioned, as in that, you have to make a proposal to become a node operator, and then there are proposals to choose where you go, as in like what subnet you're assigned to. So that is a nice property that we can actually say, like, hey, we have a lot of evidence to suggest that these nodes are completely independent and they're composed of these jurisdictions. So that's nice, but still 10. I don't know. This is something that seems very subjective, and I haven't seen really good research or empirical evidence to help us know how many nodes we need. So I don't know if anyone really knows, because obviously Bitcoin and Ethereum those are secure enough for billions and billions of dollars of value to be on them, because they have been secure enough.
Yeah.
But we don't really know about the other side. So we kind of have some idea. So for example, Chainlink secures a whole lot of value. I don't think they've had, people still use them. I don't think they've had any major incidents. Do you guys know of major Chainlink hacks, like of Chainlink itself?
No, I haven't heard of that. But
so they have a similar model to the subnet model, where it's like, I think their most, at least for the price feeds, I think their most secure price feeds were like 31 nodes. So very, very similar.
Yeah, but ultimately,
and then
what you're talking about is like taking $1 billion, instead of storing it onto a smart contract or a canister, you split that money into 3 different canisters, 3 different subnets. And
you can do that.
And then because I often wonder, like when these attacks occur, there's like a malicious backdoor within the smart contract, some social engineering, and how do you, as a system, as a network like ICP, how do you determine whether there's an authentic transaction that's trying to move $300 million authentically versus a hacker who's trying to move $300 million? Like, I don't think you can know that.
Yeah, no, not if it's a smart contract bug.
So that means that you try to mitigate some sort of disaster by splitting that $1 billion in 3 different canisters, because then you're not losing $1 billion, you're losing 300 million.
You would need, so right now there's only one threshold ECDSA subnet with a backup. That's the last time I really dug in. So we would need to deploy more ECDSA subnets. So we can do that. You couldn't do it at this moment, but it's like, it could be done. So yes, that would start to mitigate the risk. But in my opinion, that's mitigating the risk in a not the most elegant way.
Yeah.
I would love, so these are future things I would love to see. So currently, that's a practical way to do it, how you said, and I think it could be done relatively quickly. I don't think you would need major protocol changes to do it. You would just deploy more of these subnets. You could also increase the size of the subnets, but then you'll get latency and you'll get more latency and more cost. They're working to increase that signing threshold from 1/3 to 1/2. So that would help as well. And then what I would love to see, this is like my dream scenario, is that basically a couple things. One, the node operators would use zero knowledge identity solutions so that they become completely anonymous by default, but the protocol can prove that they are legal entities and they're independent and they're in certain jurisdictions. So then no one would know who they are, and they, maybe most importantly, they wouldn't know who each other are. And if we could somehow hide from them even what subnet they're in and what canisters they're running, that'd be really nice. Add on top of that trusted execution environments. So AMD SCV SMP is like a secure enclave technology that Dfinity is working to implement. That would make it a little bit more difficult for the node operators to see what's going on and to change the software. And you get attestations actually from those hardware modules, I believe, of the code that's running. So the protocol could, have some sort of assurance that you aren't running malicious software. And then add on top of that, so the node operators, it's going to be difficult to break into their nodes and change the software. It's going to be difficult for them to find the other node operators to collude with. And then if we can add a rotation of the node operators between the subnets, then you start to create security as a network effect of the number of independent nodes in the whole network. So my one subnet is possibly made, basically all subnets are just as secure as every other subnet. Let's see, you gain more security, the more honest nodes there are in the network. Whereas right now, you're just your own subnet. Whoever you have, that's who you have. So if we have this shuffling, combined with the secure enclaves, combined with the zero knowledge, anonymity, I'm wondering if that creates an extremely secure situation where, it'd be extremely difficult to collude, and it'd be difficult to hack if you had subnets of sufficient size.
Yeah, it makes sense.
Yeah,
it seems like that's the idea of like term limiting, like in modern day governance structures, right? For that reason, you don't want like someone in politics or positions of control around for decades at a time, because it's almost like collusion is certain.
Yeah.
Or at least probability increases, right? You want to shuffle them in and out, keep new players in and out. So it makes sense. Like
you have to be a little bit careful, because the last time we looked into this, some people did some math on this, and if you don't have enough like node operators, you might shuffle too many dishonest node operators too often into subnets. So
I see.
But these are just future ideas that I think would be awesome.
So can you speak on a little bit of like the fluidity as far as like how the DAO? Well, I guess you said that the foundational organization is basically in control as of right now. So how quickly are changes to the protocol being implemented as far as like what you've observed in comparison, I guess, to something like Bitcoin, right? Where things basically occur like
once every 4 years.
Oh yeah. So that's the trade-off. That's the positive side of the trade-off.
Yeah.
The protocol's being upgraded and changed all the time.
Okay, good.
On a very regular basis. There's tons of work going into it, and there are lots of changes being pushed.
Yeah.
Sometimes changes will be pushed actually very, very quickly. Like if a subnet goes down for some reason, then a fix can be pushed out quickly.
That's good.
So that's a concern, but it's also, I don't know.
I think
it's how do you make something that's complicated? So
yeah, I mean, we have this like we appreciate DAOs, right? We understand like this is the ultimate grand vision of Web3, getting us to the point where all this technology can be governed by its own users, right?
Yeah.
That is like the killer app of tokenization, I guess, as far as like what we can see, at least outside of like meme speculation
or money.
Yeah, exactly. So, but the consequence of that, like doing that, trying to execute on that too early within like an ecosystem's initiation point, doesn't seem to like usually produce fruitful results, right? It's kind of like you want to maintain some sort of sense of control for an undetermined amount of time. We don't really know what that threshold is.
Until the plane can fly.
Yeah, that's what we like to say. Like whoever's putting this plane together or designed it has to build it also, right? Yeah. So that takes a period of time of engineering and re-engineering, right, to figure out what's the optimal strategy of flight. Yeah. Right. But once you're there and the community and the consensus forms around that, then passing of the torch makes sense.
Yeah.
So it's good to hear from my perspective that ICP is still in that like flexible state, because you just brought up a bunch of like solutions potentially that now, like, it's not like, in the Bitcoin community ecosystem, everyone's like OpCat, right? When OpCat, nobody knows when that's actually going to happen. Maybe never, right? So there's no actual solution to programmability native to L1, right? I wouldn't wait around for that.
No.
Right? And we can't, right? Us as developers, we've got to seek, solutions today, right? Yeah. Which is what's leading us in this direction, right?
Yeah, and if the DAO is itself properly decentralized with proper governance, with checks and balances, then I don't think it's that concerning. What's concerning is if it doesn't have those things. So, there's trade-offs.
Okay.
But I think we can get there. I think the Internet Computer DAO, what's really awesome about it right now is it's extremely transparent. You can see that DFINITY votes with like 90 plus voting power. You see it. Yeah. You see what proposal they voted on. You see like the binary or the hash of the binary. I assume actually you can see the binary itself. Yeah. You see everything that's happening. You can see the history of it. So if we add some checks and balances on it to make it so that unilateral power cannot form and, have different types of voters, maybe do some kind of logarithmic voting thing. And there's all kinds of mechanisms we could do to improve it, but it is a transparent process that is controlling the protocol. So that has been launched and has been live for years now and actually works, and they actually use it to push things. So.
Yeah, I totally agree. I think DAOs are extremely critical, but when it comes to like building applications, you can't really rely on the community to finish building anything, because they just don't have like the coordination to actually execute on something, at least for the most part. But I'm curious as to the interface between ICP and Bitcoin. Can you talk a little bit about that?
Yeah, so that goes to the threshold ECDSA protocol. So usually when a user interacts with Bitcoin, you have an ECDSA. ECDSA is the elliptic curve digital signature. Oh, shoot, I don't even know. But ECDSA is the signature scheme, right? That's how you authorize sending UTXOs, etc.
Yeah.
So generally, you have a private key that's in one place, right? I have my private key. It's a string of characters or whatever. You might have a seed phrase that you could chop up and have pieces go everywhere else. But you would have to have all of those in the correct order to be able to do a signature.
Yep.
What a threshold ECDSA scheme does is it actually creates. There's never one private key that exists. There are only key shares. And you don't need all the key shares, and you don't need them in necessarily a certain order. You just need a threshold. So it'd be like any 10 out of the 28 shares can sign. That's how the threshold scheme works on the Internet Computer. What's nice about the threshold scheme on the Internet Computer is it's a very simple API, and basically any canisters can access this. I can access it through JavaScript, through Python, through Rust, through Motoko. It doesn't matter. It's very general purpose in nature. I can have my decentralized cloud application and, oh, hey, I need a signature. Go get your signature from a place that is, relatively decentralized. That key is never on one machine. That lets you actually sign true, real Bitcoin transactions from the Internet Computer. You can actually craft a true Bitcoin transaction, send those bytes over, and get an actual signature back, and submit that directly to the Bitcoin network. ICP also has APIs to do that. So we can write to the Bitcoin network. We can also read from the Bitcoin network, because there's a subnet that's actually reading Bitcoin blocks in, coming to consensus on those, Right now, I think it only gives you the UTXO set, but in the future they could expand that to give you. Actually, I think on the roadmap is to expose the block headers next, and then yeah, I mean technically I think you could expose anything, but what's nice is there's consensus on the Bitcoin blocks from ICP. So ICP is actually verifying certain things, and then there's a very simple API to just grab those UTXOs. So you can read UTXOs, you can get some fee information as well, and you can sign transactions and send them. Soon we'll also have Schnorr. So same thing as Threshold UTXO, but it'll be Threshold Schnorr. And we'll also have EDDSA.
Yeah, it makes sense now because typically you create a backend system that manipulates the UTXOs and whatever app that you're creating. But instead of doing that, and instead of having your community rely on your, I guess true nature, you could just instead write this smart contract that manipulates these UTXOs, and you can have the community, if they could, technically verify that what you're doing is, what you're actually trying to do.
We can create decentralized indexers, right? We can have all the software deployed to the computer. You know that all state changes, everything it's reading is coming from Internet Computer Consensus. So it just decentralized. Anything you had to put on AWS, if you could get it onto the computer, it just instantly gives you more decentralization, probably more security and more transparency.
Yeah, I like that because of that transparency. Because it's important whenever you are creating an application, and the whole point of blockchain is to reduce the trust. And all of a sudden you create an application, and then your community has to trust that you're doing things correctly, or you don't have some sort of back end, opening to kind of manipulate whatever it is that you're doing. Then you're sort of doing the opposite of what blockchain is intended for. And so if we could just rely on this transparency layer, which is these smart contracts, then now all of a sudden we have this programmable layer on Bitcoin through this ICP infrastructure.
Yep, exactly.
Is that at all what you think the direction of?
I mean, in my opinion, of all side chains,
sounds like it, right?
Yeah.
Obviously, you have to understand, okay, how many nodes, what's the Byzantine fault tolerance? But if you're okay with that, ICP gives you gigabytes of memory, hundreds of gigabytes technically of storage space, gigahertz of CPU. It's like a cloud environment. You can use JavaScript, TypeScript, Python, Rust, and you can actually write, sign actual Bitcoin transactions and read the actual UTXOs. So it seems like a very powerful, very expressive Bitcoin sidechain. The Bitcoin Layers project actually listed as a sidechain, and they did an analysis. So
I was just about to ask about storage. So you're talking about 100 gigabytes of storage. Where exactly?
400 gigabytes, technically.
How much?
400 is the limit.
400, not 100. Okay, so where exactly are they being stored? Is it Gaia?
On the nodes.
On the nodes. Okay. So what is it? What kind of systems are required to run a node? Is it servers or laptops?
Very expensive. Very, very, very expensive, beefy.
Okay.
Data center level stuff.
Interesting. Yep. Interesting. So as an app developer, you were mentioning earlier, we can decide which subnet to deploy to. Is that correct?
Yeah, I haven't verified that is exactly the case, but I was looking through the command line tools the other day, and I saw some options that let you do that. So yeah, I think you can choose the subnet.
So whether you choose or not as a developer, is there a place where we can go and check who these subnet node operators are?
Yep.
Okay.
I can give that to you guys. It's dashboard.internetcomputer.org, and from there you can go see all the subnets and all the node operators.
Oh, interesting. Okay, so I'm starting to see why Benny's really likes ICP. So I don't know if you know about Track and Benny, but he's working on decentralizing his indexer, and so now he's really into ICP and he's loving it. Like he's like
You
blown
said
away.
he's using Azel?
He's using Azel, yeah.
That means
have you spoken to Benny?
We're gonna be famous. No, I don't think I've talked to him.
Okay, well, you guys need to talk then, because he really loves Azel. As soon as he sent me the link to Azel and I saw JavaScript and TypeScript smart contracts, I was like, it's over. Right? This is what you want as a developer and smart contract development.
Correct. And yeah, as we were speaking to him, it makes sense, and it's obvious again to developers, which is I think the critical friction point that ICP is maybe like has been dealing with. Is this is like an obvious home run, like from a developer's point of view, I guess, but delivering on that killer product, I guess, that showcases all of these benefits is really what.
See, that's the opportunity that we have as developers, is that we have to find a killer product.
Well, anything that integrates into, I think, Ordinal's Bitcoin L1 seems to be it, right?
Well,
because
so I feel like a super obvious first app is just a decentralized Ordinals indexer. Yeah. Is that what?
That is what he's working
building?
on. Yeah.
Yeah. I mean, that sounds obvious, right? Because this entire ecosystems of meta protocols, it introduces so many different like reliances on indexing.
That's right.
Yeah, that's what we've discovered ourselves personally.
Yeah, we discovered it extremely early on, even before we created our own meta protocol.
Yeah. Yeah, and that's what led us to work with Benny, because he was the only indexer provider actually aware of the fallbacks of this reliance, and like actively addressing and building an ecosystem around, solving this critical dilemma.
Yeah.
That, everyone else was just kind of like centralized hosting this stuff and not really talking much about it. If they go offline, whatever, dude. It's just part of the stack. Deal with it,
Yeah.
So yeah, the fact that it's all heading to ICP and you're saying like, this is the right way to go, seems to be, one hell of a collaboration in the works. And
I mean, ultimately, Jordan, we're going to have to use this as well, because we have a ton of stuff. I mean,
requirements.
Yeah, we have a lot of stuff to build. And I mean, we come from the metaverse side as well. And when you're trying to build the metaverse on Bitcoin, you kind of want to do it in a transparent, programmable way.
Yeah.
Right. Yeah. Also, you want to align as much as possible with the existing ethos that exists within the Bitcoin space. Right. Everything has to be on chain on Bitcoin's block space, period. Right. But almost like it's a non-arguable point. Right.
Yeah.
But I think ICP and it's integration points. I think this is a time to kind of build this affiliation, right, as strongly as possible.
Yeah.
To kind of fit in with that ethos.
Okay, right? Let's keep in touch a lot about this, because we can provide lots of technical support for whatever you want to build in all those questions. So
and I think that's a call to action to devs, right? Because it's you have a couple of options, right? Either you participate in this, learn this stuff, and actually build. Or you sit around and again wait for this bureaucracy of what Bitcoin governance is to actually like usher in some sort of change to fix this stuff, right?
And ultimately, users don't give a damn. They don't give a damn. They just give me the products.
Yeah, I think the future users of Bitcoin L1,
they will.
Meta protocols won't care. Like these existing, bag biased individuals, for whatever reason, it's like you introduce some vector of like non-Bitcoin.
Yeah. And
they just go off the edges, right? But it's okay, you're going to sit around flipping memes and JPEGs all day. That's all you got.
Yeah. That's right.
And so you're at a dead end. So there is a tremendous opportunity here for sure.
Yeah.
It just strengthens overall our thesis of like why we've been working so closely with the TAP ecosystem. This takes it to the next level for sure. I guess
so I think it's time. So we're pretty convinced that ICP is like very, very useful, but I would say that there's hesitation as far as sentiment goes, right? Because when we first discovered ICP, we discovered it at like 10 billion. What is it as peak market cap?
It like entered the market like something egregiously,
like 100 billion, whatever it is, but it's gone down like 90% or whatever the number is, and like it's like.
Yeah, unfortunately, that actually like skews perceptions a bit.
Exactly.
Like even if it is
even
the
us.
Yeah.
When we saw it just like release at 100 billion, whatever the number was, high, and then it just ended at low in about a year after that. It's like, it was like, well, this is not something that we need to research just because it's, you know. So what would you say, Jordan? Like, what's the sentiment right now? You being kind of like a major user of this technology, do you read this same sentiment that you know, a portion of the community has, or what's your take?
Well, so I've actually been one of the most critical negative people lately because I've been wondering this for a long time. Like, why does no one talk about it? Why does no one look into it? What, like, it has flaws and weaknesses, and I think there's things I would really like to improve. But look at you guys. Once you look into it, you see the benefits and how someone in that you know very well, super technical person, it sounds like, has decided this is truly going to help him, and you guys are even thinking about how it will help you. So it seems like there are real use cases here, and there is like, the devs on ICP are very committed, and I think they fall in love with it pretty fast.
Yeah.
And the community that we do have, like the non-technical people, a lot of them are very optimistic, and I think a lot of it is tribal and speculation based, but maybe some of them truly, you know, believe in, you know, everything on chain. Blockchain singularity is kind of what ICP's vision is. Like, all the world's computations will run on this decentralized environment. So it's confusing. Why? Yeah, I don't know why, but basically there's a small, the community itself is very optimistic. There are some people that are not. I have been one of those lately because I'm trying to find product market fit. I don't want to be like, being an engineer and having built lots of, like, you know, side projects, and, you know, me and Bob's first startup and stuff, never finding product market fit in any of the things that I thought were cool. Like, the technologies I think are cool have generally worked out. I got to TypeScript relatively early, worked out. I found Rust a long time ago, that worked out. I feel like GraphQL is working. Like, when I choose a technology, it generally works out. When I build a product or something, it's like no one else ever thinks it's as cool as I thought it was. So I'm trying to be extremely careful to find product market fit with ICP. So I'm rambling, but
No. I mean,
I don't know. I don't know.
That's every developer's concern, right? Is nobody wants to.
Yeah, product market fit doesn't matter what tech it is, nothing. It's about product market fit, and if you can find that, then everything else is, like, you know, is less important.
Yep. And I'm starting to be quite encouraged. Like, this interview is very encouraging to me because you guys seem to be very authentically. I'm not trying to push you into ICP.
I'm just
trying to explain.
This is
this is us learning about ICP. Because
this is not sponsored or anything like that.
Yeah, definitely not.
Yeah.
But yeah, it's just encouraging that it's like, okay, you guys see use cases. I didn't even know that the Tap guy was using Azel. I knew he was using ICP. So
yeah,
you know, that's awesome. The Bitcoin ecosystem itself, if there is product market fit anywhere, like the first signs of any kind of traction, I'm starting to feel like it's in this community. It's like the threshold signing, Schnorr and ECDSA, that alone in a general purpose cloud environment seems like, you know, it could be useful. Ethereum is so saturated. There are tons of L2s, tons of these EVMs that are super cheap now. So it's like, you know, there's tons of bridging solutions. Bitcoin is like fertile. I mean, it was development of Bitcoin was dead until like a year
ago.
And a half ago, right?
Yeah, a year and a half.
Yeah. So, and I kind of I always respected Bitcoin as the founder of everything, but I just kind of checked out of it because it's like, these guys don't talk about anything. There's nothing new happening. It's just the same people saying their economic arguments over and over, which I find flaws in. I also love it, like the Bitcoin standard, love it, of course. But in the last year and a half, it's like, okay, there's some new stuff coming.
Correct.
Wow. They're deploying centralized infrastructure to create their decentralized meta protocols.
Yeah.
It's so obvious that the internet computer solves this problem.
Yes.
And now it's, you guys are starting to realize it, which is very encouraging.
Yeah.
Yeah, we had the same experience, or well, not Will. Will's always been a Bitcoin maxi, but yeah, we didn't find any reason to be like deeply ingrained or interested within like the happenings of Bitcoin until Ordinals.
That's right.
And we haven't, it's been a continuation ever since of like expanding the scope of potential, right? Because we come from obviously a much more robust development grounds. Ethereum and even Polygon in its earliest phases and stuff. So, we have experience building functional apps, that can scale and stuff, right? So we're in order for these things to be deployed onto Bitcoin, there's a ton more infrastructure.
Yeah, that needed to be built in order to do it.
Yeah, but we understand if this infrastructure exists, the product delivery of like these tangible applications on Bitcoin, like the potential value it's almost uncalculable, we think.
Yeah.
Right. That's been our thesis all along. I think that's why Ordinals has so much like potential energy within it, and like just the Bitcoin ecosystem overall, because everyone has different interpretations how to do this.
Well, on top of this, I mean, we're always doing research on like what's new in crypto.
Yeah.
And I guess we have a limited view into all of crypto just because we can't look at everything. Correct. But we try very hard to look at everything. And we haven't found anything new in crypto other than Ordinals for the most part.
Yeah. Other than like you said, a saturation of L2s and 3s and stuff. And yeah, that was like the inflection point at the ETH Denver conference a year or two ago. And it's like, it's just 1,000 L2s on the way. Like you can only talk about L2, L3, like on Ethereum for so long.
Yeah.
Right?
And all of them are just copy pasta.
Yeah.
It's the same L2, just reskinned with a different brand.
Yeah, so we follow
layer 7s. So layer 7s is where it's going to be at.
Yeah, that's right.
That's going to be wild. Yeah, I mean, but it's fine, right? If that works, it works. It's okay. It's just that's not where we tend to gaze our interest, because it becomes redundant. So this whole, like you said, it's fertile grounds here on Bitcoin.
Mm-hmm.
It's fascinating everything you're telling us. It's like, man, now like Will, I could see it in your head. We've already been wondering like how we're going to build out these metaverse apps.
I know how. I can do it.
I can tell. You figured it out during this call, so that's very important.
Yeah. Yeah. So I think we got to remain critical, but from like a technical perspective, like this makes a lot of sense. Like, but I think Iman can explain it best as far as like the sentiment is the audience right now are essentially degens, and they want number to go up, and so if they look at something like ICP, even though it has like a lot of technical capability. But they might not see number go up potential, and so therefore no one really talks about it. It
just hasn't been packaged in that lightning in a bottle degen formula.
Ultimately, I mean, ICP is very useful, but it's all about the product market fit. Like I don't know if anyone cares what tech you use, as long as the product that you're offering has number go up potential.
Yeah, and that's an unfortunate thing. It might not align with the ethos of ICP itself, like that community, because I think the vision of blockchain singularity, right, is like it almost seems to transcend this notion of number go up, right? It's like let's secure the internet a little bit.
That's
further,
true,
right? Like so, maybe it's okay. We missed a few cycles,
but I totally agree with what you're saying. It's just that the audience right now is number go up people. And so if you're going to find product market fit, you got to cater to those people, right? And that's the discrepancy here.
Yeah. So the question is like, what is the motivation? Is it to cater to that demographic? For what end? Is if you successfully deliver products to that existing, that is the liquidity base of our industry as of today.
Yeah, unfortunately.
That is like the only model of execution where you actually have a sensible like 10-year, 20-year longevity probability case, right?
Yeah.
But that is the way it is, right? So maybe that's something, that needs to be more talked about potentially.
Yeah. All right, Jordan. So it's been about an hour. I really appreciate your time. Any final thoughts and takeaway from this discussion? Like, do you feel a little bit more hopeful that there's gonna be developers that actually find product market fit here, or
Well, I was until you were like, it's just all degens doing degen stuff.
Yeah.
Yeah.
I mean,
we wrestle with this idea too.
All the time.
Like, do we create like useful things, or do we create things that people can speculate where the number can't go up? And so like it's about product market fit. Is like, you got to understand the market.
Yeah.
Yeah. So I was feeling though, like the fact, yeah, like I said, it looks like ICP can provide utility to this emerging Bitcoin developer ecosystem. You guys see it. The Tab Track guy sees it. Bob sees it. It's starting. That's encouraging. And maybe we just go first into this market, find product market fit as the infrastructure for all these tools that are trying to do these meta protocols, have these indexers doing all this off centralized cloud-based stuff. Let's just go in there and decentralize it, and maybe grow from there. So I'm feeling better about that direction after this interview. So, and awesome that there are people like you that will actually look into, try to truly understand protocols. I don't sense tribalism here. So
yeah, for sure.
That's great.
Yeah, ultimately, I mean, that's sort of like, I guess, the unique thing that we provide as a podcast is that we're actually trying to build stuff. And typically, if you create a podcast, you don't typically build stuff. And so you're not thinking about it in this way. Mm-hmm. What you're thinking about is catering to your audience about, which thing is going to go up. Mm-hmm. You tell me which thing is going to go up, and then, that's the content. Yeah. And so we're trying to, actually do stuff here. So that's why this is interesting to us. But
sweet.
Yeah. Yeah, Jordan. So again, thank you so much for your time. I definitely, we need to keep in touch. So we're going to have more technical questions that probably don't fit within a podcast environment.
Yeah. So
I want to stay in touch. And if you want, I can put you in touch with Benny just to have you guys meet and stuff. So I really appreciate your time. I guess, how does one like start with ICP? Is there like a specific like document that you want people to read, or like where does one get started for something like this?
Let's say you're a TypeScript or JavaScript developer.
Yes.
Maybe the easiest way is to just read the Azel book. I can give you guys the link.
Okay.
The Azel book shows you just how to install Azel and just get going super fast.
Oh yeah.
If you're a Python developer, we have the Kyber book. That's for Python. If you just want to dive into Internet Computer in general, internetcomputer.org. Like you guys said, it's a little, I don't know, flashy, intimidating. I think the Azel book, for example, we try to really keep it short and simple. So that might be a good place to start. I can give you guys all those links.
Excellent.
Okay. Yeah. Yeah. Again, thank you so much for your time, and everyone else. All the links will be in the description. Thank you guys for watching, and we will catch you in the next podcast.
Peace.